Hi, this is my video number 67 and it is a definite integral, starting of definite integral, and it is chapter 1. Okay, before going to know what is definite integral, you should know the simple things, and you know it from your physics of first year. That is, suppose x dx integration 2 to 6, then what is this? x dx का इंटीग्रेशन कितना होगा? x square by 2 to 6. Then this is called the lower limit, this is called the upper limit. This is 2, lower limit 2, upper limit is 6. First you have to put the upper limit value here in place of x, that is 6 square by 2, and put minus, then lower limit का value यहाँ put करना पड़ेगा, minus 2 square by 2, that is 6 square 36 by 2, that is 18, minus, that is 4 by 2 is 2, that is 16. Now look at here. Here it is y dx, x dx. Now take the graph of y is equal to x. What is the graph of y is equal to x? This is the graph of y is equal to x. Line y is equal to x. I am taking from 2 to 6, means it is 2 and it is then it is 6. This y is equal to x, this line y is equal to x, suppose this line is y is equal to x and this is 6. I am taking that figure in this place. It is y is equal to x, this line is y is equal to x, this line y is equal to x, this is my x axis and this is my y axis, and this is the point 2 and this is the point 6. Now take this part, what is this dotted points, take this part, this is what? This is a trapezium. Now we know the area of trapezium is equal to half sum of the parallel sides into height, as it is origin, and as it is 2 is what? 2 is from this point to this point to this point to this point 6. Now this length of this is 4, which is height. Half, if it is 2, then y is equal to what? Y is equal to 2, because x 2, you have to, the formula is y is equal to x. When x to y automatically 2. If y is equal to x square, then tell me, when x is equal to 2, y will be 4. Now when x is equal to 6, put here x is equal to 6, you will get y, that is 6. If y is equal to x square, if x will be 6, y will be 36. Okay. Now similarly, if for x is equal to 2, y 2, x is equal to 6, y is equal to 6, and y is equal to 6. Take, this is a trapezium. Area of the trapezium is half sum of the parallel sides into height. What is sum of the parallel sides? That is 2 plus 6 into height. What is this height? It is 4. It is 8 plus 4 into 4. That is 32 by 2. It is 16. Then area is equal to 16. Here in definite integral, area is definite integral value is what? 16. So from this you know that area is what? Is definite integral. Area is what? Definite integral. So in definite integral, we know definite integral means the if x dx, if x dx will be there, it is x square by 2 plus, it has no definite value, so it is called as indefinite integral. Why no definite value? Because c is there, you can put in place of c, you can put 1, 2, 3, whatever you can. But in definite integral, there is a lower limit, there is a upper limit, and its value is a definite value, that is 16. In this case, it is indefinite due to the word c, but here there will be no c. Now integration, it is x square by 2, and the result is you have to put the upper limit, then the lower limit, then you find the value. Now I am going to teach you limit as a sum. How it comes? Look at me. Now I am erasing this part for your convenience. Come to the proper point of this chapter. This chapter is limit as a sum. As a sum. Suppose this is a curve, y is equal to fx. This is your x-axis. This is origin. This is y-axis, and this is a. And suppose this is b. Similarly, here this is x-axis. This is y-axis, and this is the curve y is equal to fx. Y is equal to what? Fx, and this point is a. This point is b. Okay. Now look at me. Suppose I want to find the area. In this case, suppose this is A, this is B. So here area is what? Area is A, and this height is what? Fa. Okay, I am writing it is very small, looking very small. Suppose this length is called, if it is A, then this is Fa. Then area is equal to what? Area is equal to length. Length into breadth. What is length? Here suppose I am taking, it is B minus A. B minus A. I am not dividing it by, suppose I am not dividing it. That is B minus A by 1 into Fa. Fa means this. Okay, this is the thing. Now here what is the area? Area is equal to, I am writing area is equal to B minus A, means no division, B minus A by 1 into this height. This is FB, this is FA, this height is FA. Okay, I am not writing because it is not looking properly. This height is FB. Now tell me, first case, area is very small. In that case, it is not equal to its proper area. In this case, the area is very large. It is also not equal to its proper area. Proper area is this much. Okay. Suppose I am doing another figure and I am doing erasing it. It is not required for you. I am just explaining you that thing. That's why I am taking this. So, suppose this is the curve y is equal to fx, and this is my x-axis, this is my y-axis. I am dividing it in two parts. Suppose this is h and it is also h. Suppose I am dividing this figure to find the area. I am dividing in two parts and taking each part as h. This part I am dividing two parts, one h, another h. Then clearly h is what? B minus A. This length is A, this length is B, so this length is B minus A. In the first case, I am dividing by 1 because I am not taking, I am taking it wholly. I am taking this part. Okay, I am taking this part in the previous thing. And now I am dividing three parts. Now area is what? Area is what? This one and this one. Because h into this height is fa, h into fa. This is this. And this second part, the area is what? H into, it is a, and if it is h, it is a, it is h. Then what is this point? Clearly it is a plus h. Okay, if it is A and it is H, clearly this is what? A plus H. And this area is, means height, Fa means height, length into breadth, that is H into Fa. This is the area of the first part. Then what is the area of the second part? This is the length and this is breadth. What is the breadth? If it is A plus H, this point is A plus H, then what is its height? f of a plus h, then this area is h, f of a plus h. Now you can take common h and you can write fa plus f a plus h. Okay, and this is the way. Now look at me. If I will take it in three parts, then look at me. In first case, area was what? This much. And in the second case, the area is coming as what? This. If I will divide this in three parts, what will happen? This is the A. Suppose this is A, this is B. I am taking in three parts. Okay, three equal parts. Suppose this one, this one, this one. This is more near to our area. That is this is. So I am taking this part. Okay, this part. Now this figure and in this figure we are approaching. This is more approaching to this area. Okay. If I will divide it this length, if I will divide in four parts, then it will be more. Now, similarly, if I will continue like this, then tell me, for finding the total area, for finding the total area, if I will divide it in many parts, that is 100 times, 200 times, 300 times, then the area will be more closer to this. Okay, this is my approach. Now look at this figure. Suppose this is my y is equal to fx, and this is my x axis, this is my y axis, and this is the point A, this is point B. Suppose I am dividing this into n parts. Then what is h? Each part, this part, this part, this part, each part has length b minus a by n. Okay, and look at that. Each part has a length what? B minus a by n. This is a, means from origin to this point it is a. From origin to that point it is b. And length of this portion from this to this, it is b minus a. And I am dividing it into n parts. Then each part has length b minus a by n. For that first case, I am taking n is equal to 1. In this second case, I am taking n is equal to 2. In the third case, I am taking n is equal to 3. And in this case, I am taking n. And I am telling, if you take n is equal to 1, then the area will be this. Okay, if you will take n is equal to 2, then the area will be this and this. If you will take n is equal to 3, then area will be this and this, then area is that. Okay, if I will take n is equal to 3, 4, 5 and so on, then the area will be like that, it will continue. If I will take n is equal to 100, then it must equal to this area. If I will take n is equal to infinite, then figure will be like this. This is if this is the curve, I am taking infinite, means very small area. Then this area will be nearly equal to this area. Okay, so I am taking, it is very clumsy to see, so I am expanding it. Now look at it. First point is A, the next point is what? This length is A and it is h and it is a plus h. Next is what? A plus 2h. Next is what? A plus 3h. This is h, this is h, this is h. First point A, this is A plus h. This point A plus 2h, this point A plus 3h. Continuing in this manner, you will come to this point, it is A plus n minus 1h and B, that is A plus what? A plus nh. A plus nh. And here what I am taking. I am taking, there are two, you can find area in two ways. That is the lower areas. In higher studies, you will, this will be termed as LPF, lower partition. That is lower partition of the function, LPF. You will know in future, LPF. Means I am taking the lower partitions. Look at here. What is that? I am taking the marks here. Here, this one. This is the lower partition area. Because a small area is there. And this is the second part. This is the third part. A small area here, here, here will remain. And here in this case it is looking properly, and that is this area. Now total area is equal to this area plus this area plus this area, like continuing in this. This is the last. The first area, this length is h, this height is fa, then area is h into fa. Next area, this is h, this is a plus h, this is h into a plus h. There is small minor problem, you can adjust it. Now look at this area. Total area is what? H. This is h into this height is fa. Mind it. This is fa. This area is hf. Next, this length is what? H. And this height is a plus h. This height is fa plus h. Now this area is h into fa plus h. Next area h. A plus 2h. Similarly, continuing in this process, the last area is what? H into f. It is a plus n minus 1h. So the height is what? f of a plus n minus 1h. And you will find the exact value in what condition? If this length n, because my h is what? H is b minus a by n. If this n tends to infinite, you will find the exact area. That is limit. That is, look at here. I am taking this is what? I am taking this h. If I take common h, then it will become fa plus a plus h, a plus 2h, a plus n minus 1. N minus 1h, that is summation. Summation of what? This is fa, this is fa plus h, fa plus 2h, fa plus n minus 1h. That is summation of f, here f, a plus rh. I am taking it rh, and taking r here 0, r here 1, r here 2, r here n minus 1. So r starts from 0 ends in n minus 1. So total area is h into summation of f a plus rh. R starts from 0 to what? N minus 1. And its value, I am taking this as limit. What is that limit? Limit n tends to infinite. N tends to infinite, because what is that n? If these partitions are very large, that is partitions means number of partitions is n. If it is very large, then its area is equal to, in that second figure, it is the figure 1. In that second figure, what is that area? I am taking the upper part. So it is called as lower partition of the function. It is called as upper partition of the function. Although these two terms are not in your level book, but I am telling it to know some advanced things. This is what a to b fx dx is what? This area a into f a plus h. A plus h. This height is f a, mind it. But that height is f a plus h. I can take this area. This is the lower area. This is the upper area. So it is written as UPF. Upper partition of the function. It is lower partition of the function. Okay, you should not remember that things. You see just only this thing. H into f a plus h. What is this area? This area is h f a plus 2h. This is h. This height is a plus 2h. F a plus 2h plus h. H a plus what? 3h. And this is what? H into f a plus what? nh. Okay. Now look at here. It is limit n tends to infinity. N means number of partitions going to infinite. Okay. If I will erasing this, what happened? Look at here. I am taking h. I am taking h common. Now look at here. It is h. And it is f a plus h. F a plus 2h. F a plus 3h. So f plus rh. R is here 1. A plus rh. R is 1 here. R is 2 here. R is 3 here. And you are continuing to getting R is equal to h. H into summation of R is equal to h. You are taking common. H into f a plus h. F to a plus 2h. H a plus 3h. I am taking h common. So it becomes what? It becomes f a plus h, a plus 2h, a plus 3h, and that is r is equal to 1 to n f a plus rh. Okay, r is equal to 1, r is equal to 1 to r is equal to n. And if what is this n? If I am taking, this is the language of taking number of partitions tends to infinity. If number of partitions tends to infinity, what is its length? Then length of each partition tends to what? If n tends to infinite, then h tends to what? 0. If n tends to infinite, this implies h tends to 0. I am taking just limit n tends to infinity. I will do some problems about this. First know this theory. Okay. Then after I will teach you its problems. It is very, very easy problems. Sometimes in exam it will come. Okay.